All right, thanks for watching. And here's a modern problem that requires an ancient solution. Namely, we will find the maximum of the function ax plus by plus c squared over x squared plus y squared plus 1 without using any calculus. And in order to do that, we use an inequality that's extremely important in linear algebra called the Cauchy Schwarz Buniakowski inequality, which says that the absolute value of the dot product squared is less than or equal to the length of u squared times the length of v squared. Now, how can you write this of this form? Well, look at the top here. Ax plus by plus c squared. Notice this is the dot product squared of two vectors, where the vectors are abc and xy1. So great, because this is u dotted with v squared, but of course a number squared is the same as the absolute value squared. So now this becomes less than or equal to the length of u squared times the length of v squared. And therefore, in this case, we get that ax plus by plus c squared is less than or equal to a squared plus b squared plus c squared, because that's length of u squared, and the other one is x squared plus y squared plus 1 squared. And the cool thing is we can manipulate this to become our function, because then what this implies is that ax plus by plus c squared over x squared plus y squared plus 1 is less than or equal to a squared plus b squared plus c squared. And in particular, the function f is never greater than a squared plus b squared plus c squared. Now, this does not prove that the maximum is this, because the biggest value of f could be smaller, but once we've shown that this number is actually attained, then we're done. Then it is a max. Because let's say this is a squared plus b squared plus c squared. Now, the function could look like that. However, if we show that there is a point where we have this number, then we're done. Then, in fact, it is a maximum. And for this, let's just manipulate this equality a little bit to figure out our guess. So now, suppose that f of xy equals a squared plus b squared plus c squared. Not necessarily true, but this will help us find our guess for the maximizer, if you wish. Then what we get is ax plus by plus c squared over x squared plus y squared plus c squared, plus 1, equals a squared plus b squared plus c squared. And then let's cross multiply. So ax plus by plus c squared equals a squared plus b squared plus c squared times x squared plus y squared plus 1. And now the trick is, just for comparison, to factor out c from both sides. So we get c squared, and then I believe a over cx plus b over cy plus 1 squared equals c squared, and then I think a over c squared plus b over c squared plus 1 times x squared plus y squared plus 1. And then, well, the c squared cancels out, and then we get a over cx plus b over cy plus 1 squared equals a over c squared plus b over c squared plus 1 times x squared plus y squared plus 1. Now, once again, it's not a proof, but it highly suggests if you compare both sides, like a over cx and then a over c squared, it suggests to use x equals a over c and y is b over c. So we just need to check those two values and see if f equals to our number here. So let x be a over c and y be b over c, then f of a over c, b over c, that is a times a over c plus b times b over c plus c squared over a over c squared plus b over c squared plus 1. And then you can multiply both sides by c squared. So this one gets under the square and just multiplies by c. So that becomes a squared plus b squared plus c squared. And then the bottom multiplies by c squared. So a squared plus c squared plus c squared. And then squared. And then the nice thing is this cancels out and we end up getting a squared plus b squared plus c squared. Yay! So it's actually attained. The last thing just to mention is the case c equals 0. So for c equals 0, then f of xy is ax plus by squared over x squared plus y squared plus 1. But in that case, I'm suspecting that the maximum doesn't even exist. Because, for instance, if you take the case a equals 1 and b equals 0, then you get x squared over x squared plus y squared plus 1. And in that case, the maximum doesn't exist because it would be 1, but that's only attained as x goes to infinity and let's say y equals 0 or something. Yeah. All right, I hope you like this. If you want to see more math, please subscribe to my channel. Thank you very much.